Hello and welcome. In this video, we are going to take another look at our memory demo. Our memory demo is kind of a loose collection of examples that sort of show you a little bit about how the Java framework utilizes memory in creating objects and using the constructor. This video is part of a larger series of videos that focuses on the fundamentals demo and the fundamentals of the Java programming language. And in an earlier video, we took a look at the double equals and the equals function in conjunction with the equals ignore case from our strings video. And then we also took a look at hash codes and some of the limitations of the double equals and the equals function. Now, the first two videos might not have been completely clear in their purpose, and hopefully this video will help out a little bit, although this one's also going to get pretty sophisticated pretty quick. And so let's go ahead and get started with our function signature. Again, our function signature is not going to be all that interesting. We're just going to create this little helper function that doesn't have a return value called is__03. We're also going to have to do a little bit of setup here for this particular example, and then I'm actually going to have to create a new class that I'm going to call custom object. And so we're going to start off first by creating that custom object class. And then I'm going to go ahead and jump into a new topic here of being able to inherit from, in this case, our object that is provided by our Java framework. Now, this is going to seem a little strange because it is implied that everything inherits from object. I'm just explicitly doing it here so you can appreciate what's actually going on. And we'll talk about inheritance in other videos. What I want to do, though, is I want to focus on a particular method that we utilized in our earlier videos, and that is that dot equals method. And what I want to do in this particular video is I actually want to go about in overriding it. So to begin with, what we want to do is we want to go ahead and set up a very, very basic custom object. It's not going to be very interesting. As a matter of fact, I'm going to be rather lazy when I do this. I'm going to go ahead and use public fields here, which again is not a great idea, but this is just to speed up this particular example. I'm going to have a public string ID. I'm going to have a public name, a public string name. And again, we can add a couple of other fields on here if we want to. How about one more? We'll go ahead and have a public integer, and let's just do age. And again, I'm not even going to initialize any of these. I'm just simply going to declare them. And what I'm going to do is I'm going to have a public constructor here for custom object. And the only thing that it's going to accept then is going to be a string ID. Again, I'm going to be very, very lazy in this particular example here, and that the constructor here is going to not even check anything. It's just going to say this.id is equal to ID, this.name, and then this.age is going to be equal to 0. And the idea is it's just basically setting some default values here that we can then go in and modify and tweak. Now, the only other thing that I do want to go about doing here is I do want to go ahead and have a public Boolean equals, and I want to pass to it then an object. And to keep with the Java documentation here, actually I want to take just a second here, make sure that we've got the same variable that the Java documentation uses. I'm just going to grab one of my other ones here. So age dot equals, and you can see here it's object obj. So in this case, just to keep consistent here. And then you'll get a little warning here that says you need or should consider adding the override annotation. And the reason why we want to override this particular method is we want to have a custom equals based on how we think the object should be compared. In other words, maybe you don't want to compare all of the fields to determine whether the two objects are equal, or maybe you do, or maybe you just want to compare some of them. And so the idea here is that we're going to create our own equals function that will allow for us to compare our two objects. And then ultimately, what we're going to do is we're going to return then a true or a false. And I'll tell you what, I'm going to go ahead and set this up here. I'm going to go ahead and create a results variable. I'm going to go ahead and set it equal to false, and I'm simply going to return our results. And again, depending on whether you want to set it for true or false, we'll fix that in just a second. And then what we'll do here is we'll simply calculate our results based on how, and rather what fields we choose to compare. Now, I'm going to keep this one pretty simple. I'm not going to focus on the name and the age. For whatever reason, I'm going to say that if two objects have the same ID, that they are in fact the same object. Now, you would probably agree that that's probably a terrible idea to do, but what we'll do for this first example is we're just going to do this dot ID dot equals ignore case, and what we'll do is we'll compare it then to our OBJ. But the problem with it is you'll notice then that the OBJ doesn't have the fields associated with it to identify that it is in fact one of our custom objects. So the very first thing that you want to do is discover then the type of the object that is being passed, or you can attempt to cast it to a custom object. Now, again, that's going to get us pretty quickly out of the realm of where we want to be. So for right now, what we're going to do is we're going to make a tremendous assumption here that our OBJ is in fact an object of custom object. And again, that is going to be a rather bold assumption on our parts. We'll come back in a later video and we'll see how we can correct that. But what we're going to do is we're going to cast our object to a custom object so that then we get the ability to get the ID. And so in this case, then we'll have our OBJ dot, and I'll tell you what, I'm going to go ahead and do, just so we have a little bit better with our field recognition, I'm going to go ahead and create one more variable here. We'll call this a custom object, OBJ temp. And then we're going to set then our OBJ temp equal to a casting of our OBJ. So we're going to cast to a custom object. And there's a couple of different ways that you can go about doing this. I'm just trying to keep this example relatively simple. And again, there's a number of problems with this approach. We really do want to take a look at the type. But now what we can do is we can look at the ID associated with it, and we can compare it to the ID that we have stored in our instance of our custom object. So essentially what we're doing is we're comparing it to an instance of our custom object. So there's a number of assumptions being made here. Number one, that our ID is not null and so on, but also two, that our object that is being passed to us can in fact be converted or cast to a custom object. Now, the point with this, though, is that our equals ignore case compares two strings, and if they in fact match, returns a true. If they don't, returns a false, and you'll simply assign this to our results. And so what we're effectively doing here by doing it this way is we are ignoring all fields besides the ID. And so in other words, the ID is the only thing that matters. Now, if we wanted to include both the ID and, for whatever reason, perhaps also the age, well, what we could do is we could simply just rewrite this. And again, we're going to make the same assumption here, that we can cast our object into a custom object. But what we'll do is we'll simply make this a compound condition, so including an and then what we will do is we will simply compare this dot age, and we'll compare it to our OBJ temp dot age. And if both of those conditions are true, then that means the whole thing is true. In this case, the results are going to be true. Again, this is just an opportunity for us to play around with our equals function. So we'll start off with the first example, and then let's give this a test here. We'll go ahead and build this real quick just to make sure that we don't have any errors. And then what you can do is come up here to our main. And again, what we'll do is we'll simply just change our previous example over to 3. You can also choose to run this under your demo switch. And then what we want to do is we need to test this in our is equals underscore 03 by building a couple of objects, custom objects. So we'll start off. We're going to abbreviate here CO for custom object A. And I'm going to go ahead and call the constructor. And then for the ID, I'm going to go ahead and specify 001. We're going to do this for our custom object B. I'm going to go ahead and leave the ID is the same. And then for our custom object C, we'll pick a different ID. And then mixed in here, let's go ahead and take a second to assign some other fields here. So the name is going to be COA. The age equal to 10. And again, we simply repeat this for the other fields here. COB dot age also equal to 10. And then COC dot name. Yeah, not very creative here. Purpose is to keep this example as simple as possible so that you can still appreciate what's going on here. And I'm going to go ahead and leave the age as 10. We'll play around with this in just a second. But now what I want to do is I want to have a system.out.println, and I'm going to compare my COA, and I'm going to just say versus COB. And what I want to do is I want to see what happens when I do COA dot equals, and I want to pass my COB. And I'm also going to compare my COA or custom object A to my custom object C. And again, you can hopefully see there's all sorts of possibilities here. We're going to go ahead and build this. I'm going to go ahead and clear my screen, run my third demo here, and you can see that COA versus COB is true, which seems a little strange because the names aren't the same. Well, the reason that they are, in fact, equal is because, well, we've just decided that we don't care about the name. And you can see here that COA versus COC is, in fact, false. Well, why is it false? Well, that's because the ID is in fact different. So of course that is going to return false. We can change our behavior here by simply changing then our condition that is required for it to be equal. We're going to rebuild this real quick. I think we're going to have to actually add in one more example here because in this case we still get the same one, true and false. So why don't we go up to our example here? We're going to look at our COB here. And what we'll do is we'll change our COB to 8. And then why don't we go ahead and throw in one more example here? We didn't really compare our COB to our COC, so our custom object B as it compares to our custom object C. And then if we look at this one more time, then the first one, our A and B, is now false. Why is our A and B false? Well, because in order for it to be equal, both the ID and the age have to match. And in all three of these cases, none of those conditions are true. Now, what I would encourage you to do is to play around with your equals function. I think hopefully you can see how as the fields get more sophisticated in your custom object class that you could do various different combinations of equals. And then again, sometimes you simply want all of the fields to match. The only other thing that I would take a second to consider is also your hash code. And we aren't really going to cover that in this particular video. We covered it in an earlier video, but you can actually generate your own hash code for a given object at the time that it's constructed or when it is simply called. So as always, if you have any questions, comments, or concerns, don't hesitate to reach out to me. And thank you for watching.